Okay, so if you will turn to page 13 in your composition book. And title it 1-7, which is simplifying expressions. So this is the last section that we will learn before our test on Friday. Tomorrow we're going to review for the test, and then obviously Friday is our test. So today we're talking about simplifying expressions. One thing it's important for you to understand about expressions is that they are called expressions, not equations, because they do not have an equal sign. So if there is a variable in an expression, your goal is not to solve for that variable, but just to simplify it as much as possible. Is there anyone else that doesn't have scissors? Anybody else that doesn't have scissors? Okay, so you're going to cut out this foldable exactly the way that we did yesterday. You're going to cut a rectangle around it. And yes. In between each row, you're going to cut until the column on the left-hand side, so that it looks like this. Then put a very small amount of glue along the column and glue it on the top left-hand side of page 13. There's one right there. So glue it on the top left-hand side of page 13, like along that red line. So these are the three properties that we're going to learn that, if used, will help us simplify expressions, okay? So commutative, associative, and distributive are the three properties that's important for you to know on your test and throughout the year. So just like we did yesterday, we're going to fold back these tabs one at a time, starting with commutative. We're going to write the definition here, and then we're going to write some examples here. So let's think about the commutative property first, okay? Commutative property has the root word commute in it. So can anyone explain to me what the word to commute means? Right, to travel. So if you're commuting from school and back, you're basically moving yourself from to school and then back. Commutative property has a similar meaning. The commutative property means that you can add or multiply in any order. The commutative property says that you can move around the numbers. You can move around the numbers in your addition or multiplication problem. Okay, you can put the glue down. And it will not affect the answer that you get. For example, 2 plus 3 plus 7 is the same thing as 7 plus 3 plus 2, or 3 plus 7 plus 2. Basically saying it doesn't matter what order we number those in, it's going to get the exact same product. I don't know why it looks like that. Or it's going to get the exact same sum, the exact same sum. Okay, in another example, 164 plus 8 plus 16 is the exact same thing as 164 plus 16 plus 8. So can anyone think of why we might use this property to help us? How could we use this property to help us? Is there a reason why adding 164 plus 8 plus 16 might be more difficult than adding 164 plus 16 plus 8? Right. 164 and 16 are what we like to call complementary numbers, meaning when you add them together, you get a multiple of 10. Anytime you have two numbers like 4 and 6 that will add up to 10, it's going to be easier to add those numbers first. So 164 plus 16 is 180. Then adding 8 is easier to add to 180. Where if you did it this way, you're not going to have a multiple of 10, so it makes adding a little bit more difficult. We're going to show more examples of that in a second. Here's another one. 4 times 9 times 25 is the same thing as 25 times 4 times 9. Now that's a good example of how moving around the factors can make multiplying more simple. Because 4 times 9 is what? 36. Does anyone know 36 times 25 off the top of their head? Okay, let's look at if we did it this way though. 25 times 4 is what? 100 times 9, 900. So do you see how multiplying it in this order is much easier than multiplying it in this order? So that's an example of how using the commutative property or moving around your terms can help make simplifying easier. Okay, let's move on to associative property. So if you'll flip back associative property. The associative property says that when you are adding or multiplying, you can group any numbers together. So the associative property has that root word associate. To associate means to form a group. So this property says that you can group numbers in an addition or multiplication problem however you want. For example, 48 plus 75 plus 25. So basically what that means is you can group using parentheses either one of those two numbers into pairs that you like. So what do y'all think? Would it be easier to multiply or to add 48 plus 75 or 75 plus 25 first? So to do that, since they're already in the right order, I can use the commutative property to show that I'm adding those two first. I'm sorry, the associative property. I said that the wrong way. You can use the associative property to group those two together and show that you're adding those two first. You could do it this way too. You're going to get the exact same answer. It's just making it a lot complicated, more complicated for yourself. And another example, 7 times 4 times 5 you could choose to multiply 7 times 4 first or 4 times 5 first. The grouping is just simply showing which one you're doing first. Make sure you're writing all these examples down. So what do y'all think would be easier? 7 times 4 first or 4 times 5 first? Yeah, 4 times 5. Okay, if you'll close that one. The last property that we need to know is the distributive property. This is the property that we use most commonly. You've already seen it on your warm-up activities a little bit, so hopefully we have some familiarity with this property. The distributive property says you can multiply a number by a sum, or you can multiply each number in the sum and then add. Oh. I have no idea. I'm guessing it's this thing. Okay, so let me show you an example of this. If you did 3, hopefully you can still read this. Okay, 3 times 4 plus 8. I want you to write it twice because we're going to show the 2 different ways that you can do it. Okay? So what the distributive property says is that you can add these first and then multiply, or you can multiply first and then add. So basically, 4 plus 8 is what? 12. 3 times 12 is? Okay. Or you can multiply first. So you're going to distribute 3 to the 4 and the 8. So 3 times 4, 3 times 8, and 12 plus 24. Good. Now, normally in this type of example, we would probably choose to do this way, okay? But the reason why the distributive property comes so we use it so often is because sometimes you don't know what one of these is equal to. For example, if you had 3 times x plus 6, now I can't add x and 6 because I don't know what x is equal to. So instead of trying to add x plus 6, I'm going to simplify by using the distributive property to distribute the 3 to the x and the 6. So 3 times x and 3 times 6. So when it tells you to simplify these expressions with variables, that's all you're doing is simplifying it as much as possible. You are not trying to solve for x. You cannot solve for x because you don't know what this expression is equal to. So don't try to solve for x. Just simplify it as much as you can. Another thing with the distributive property that your homework is going to ask you to do and is very, very helpful when multiplying, it's going to ask you to write each product using the distributive property. For example, 5 times 107. 5 times 107. So basically, we're starting here, and it's asking you to break it apart like this. Because multiplying 5 times 107 might be more difficult, but you can multiply easily. Does anyone know how I could break that apart? Good, 100 plus 7. Because multiplying 5 times 100 is easy, that's 500. And then multiplying 5 times 7 is easy, that's Then all I have to do is add 535, which is 535. Here's one more example like this. 9 times 52. So how could I break apart 52? Good. So I'm going to do 9 times 50 plus 2. 9 times 50. 9 times 2. And then 450 plus 18. Do we need to do more examples like that, or do you guys understand? Okay. The last vocabulary word in this section is like terms. So like terms comes in when you are simplifying expressions with variables. For example, if you were trying to simplify x squared plus 12x plus 30x plus 6. Remember, the goal here is not to figure out what x is. The goal is to simplify this expression as much as possible. So what are the like terms in this expression? Good, 12x and 30x. Okay, how come x squared is not alike? Because it has the exponent. Okay, so like terms are terms in an expression that have the same variable and the same exponent. So in that example, when I'm combining 12x plus 30x, what do I get? This would be x squared plus 42x plus 6. So notice, the variable does not change. All you do is add the constant. If you'll turn over to page 14, we're going to show some examples. Okay. So I know I told you guys on the very first day of school that I do require you to show your work on all of your assignments. So it is super important. I've been kind of relaxed on that because I know a lot of the section we've been doing have been so simple. But this is an example of a section where it's super important that you show your work. So I want to make it very clear to you that on your homework tonight, if you do not show any work, you will not get credit on it. And I'm going to show you some examples of what kind of work I'm talking about. So, for example, if I have negative 12 plus 67 plus 12 plus 23, in the instructions simply say simplify each expression. Okay, so you want to use those properties that we just talked about to make solving this as easy as possible. Okay, so let's start with a commutative property. How can I move around these numbers to make solving this easier? Say it again. Okay, 67 and 23 are complementary numbers, and 12 and negative 12 will cancel out, so I'm going to put those together. So I just used the commutative property to move the numbers together. Okay, now I'm going to use the associative property to simply show which pairs I'm adding together. Make sure you're writing this down. Okay, so 67 plus 23 is what? 90. Negative 12 plus 12. And then 90 plus 0 is 90. So that's what I mean when I say show your work. Show me how you use the commutative and associative property to simplify that. You may not need to use all of the properties every single time, but you should at least be able to use one to make the problem simplified. How about this one? 1/3 times 8 times 21. How can I use the commutative property to make this problem more simple? Does it make sense to multiply 1/3 times 8 first? Yes, the thing that makes the most sense is to multiply 1/3 and 21 first, and then multiply by 8. So first I'm going to use the commutative property to move the factors, and then I'm just going to use the associative property to show that I'm multiplying these two first. Why is it easier to multiply 1/3 times 21 instead of 8? Right, because a third, you can take a third of 21 without getting a fraction. 1/3 of 21 is what? Good. And then 7 times 8? Good. So this is a great example of how to show your work on your homework. I understand that you may be able to do that in your head, but I can't read your mind, so you need to write it down so I see what you did. Okay? All right, here's another one. 5 multiplied by x minus 3 minus 7x. Okay, first property I'm going to use is what? Distributive. I'm going to distribute the 5 to the x and to the negative 3. So 5 times x and 5 times negative 3. Good. Now I'm going to use the commutative property to move the 7x next to the 5x. So I'm going to do 5x minus 7x minus 15. And then I can use the associative property to group those two together, showing that I'm combining those two together. So 5x minus 7x, yes. There's my final answer. That's as much as I can do. Okay, you can go ahead and close your composition books.